looking at exercise 16. Consider the following system at equilibrium. We have a negative delta G. What will happen to the ratio of partial pressure of the phosphorus pentachloride to the partial pressure of the phosphorus trichloride if the temperature is raised? Explain. So basically this is a pretty conceptual question that you will need to think about in order to go from here. We know delta G is negative. Can we find anything else? What else can we find here?
The temperature.
The delta S is going to be what?
Negative.
How do we know delta S is negative? Yes, we have the 2 moles over here going to 1 mole of gas. So delta S is going to be negative. So what does that tell us about our delta H then?
Negative.
Delta H also has to be negative, right? Because delta G couldn't be negative unless the delta H was, if you're following your equation. So where does heat go? Goes over here on the right-hand side. Good. Now if we raise the temperature, which way is it going to shift?
The reactant.
Shifts this way. So yes, if K is P over R in this case, PCl5 is a product over the reactant. Okay, if we're shifting to the left, the reactant's getting bigger on the bottom there. So what's happening to your ratio? Ratio is going to decrease. So do remember that these pieces of information are hidden in there that you can find, like delta S. From delta S, you can figure out delta H because they gave you the specific information about delta G here. And then you can work it backwards, okay? Now for the last one here, looking at exercise 17, is kind of applying all of this information to solutions, solution chemistry, solubility product. Remember, solubility product is also a form of equilibrium, okay? So take a moment to figure out your delta G's for each, okay? And then we'll come back and go over some of the conceptual justifications and things from that. Okay, checking your values. This was the basic plug it in and get your answer. Okay, I changed mine to kilojoules. You could have changed yours to joules and then back. So, NaCl comes out negative. So that says what about the NaCl? Spontaneous or thermodynamically favored, whereas the AgCl, silver chloride, is not favored. So this one's favored. This one's not favored. Okay, now that you have the values, you can look at, is the difference primarily due to the enthalpy term or the entropy term? So what one is making them kind of different there? Why enthalpy?
Because one has a really big one and one has a really small one.
Well, definitely the numerical values are quite different. The enthalpy for the sodium chloride was like 3.6. Both are still endothermic if you didn't see that, because they were both positive delta H's. But there is a huge difference in the amounts of them. And if you think about the entropy term, you're taking a solid thing and breaking it up into two separate ions, so the entropies should be very similar. Does everybody see that? If you take one solid, break it up into two ions, your entropies are going to be pretty similar. So even though they're both endothermic, the silver chloride has a much higher positive delta H, which kept it from being kept the delta G being positive. So now from here, we would say the enthalpy term, okay, the delta H values were definitely hugely different, and that allowed for the sodium chloride having a small endothermic positive there to still come out as a negative delta G. Now I want you to calculate the KSP values for each salt. We're going to see about how they look in comparison. How would we go about calculating the KSPs? Okay, the delta G equals negative RT ln K. Here, KSP is a K. It's the solubility product, so it's equilibrium for solubility. So it can plug into the equation as well. So really, yes, that's what you're doing here. Delta G, negative RT ln, and this is now KSP being able to be applied here. So go ahead and calculate those. Okay, so did we calculate our KSPs? Are your KSPs consistent with your delta G values? What do you know about KSPs? What do you remember about KSPs? If you have a small KSP, very insoluble. If you have a large KSP, should be soluble. So that helps you answer the next question. Sodium chloride is considered to be a soluble salt, whereas silver chloride is considered to be insoluble. Are these descriptions consistent? Yes, because the sodium chloride KSP is a large value, which is consistent with being soluble. And if you have a very small value for your KSP, that means as you get smaller with your value, your insoluble becomes highly insoluble. But how would changing temperature affect delta G? for each salt. So if you were to increase the temperature, how would that change the solubility? How would it affect it if you decrease the temperature? Yes? Would increasing the temperature make it more soluble?
Yes.
Why? It's endothermic. Thank you. That's what I was going for. Because they're endothermic, so you're going to increase your solubility. Okay? And if you decrease the temperature, so this would increase your solubility. And so then solubility would decrease if you decrease the temperature, because since it's endothermic, it would favor it breaking apart into its particles. And then if you increase the solubility, how does that affect delta G? Delta G will decrease when you increase the temperature, yes, because it becomes more favored. Okay? Decreasing the temperature, your delta G is going to increase.